Let's deal now with adding and subtracting algebraic fractions. And when you add or subtract two fractions to express them as one, that is also considered simplification. But first, let's go over the concept with numbers, which is something that we are very familiar with. If you have something like a quarter plus 5 over 6, the way to add this is to ask yourself, what is the LCM of 4 and 6? And without going over the process, it's obviously 12. So mentally, what you usually do is, because you know that the denominator is going to be 12, you say, okay, this has to be multiplied by 3 over 3. And this has to be multiplied by 2 over 2. Of course, you can do this mentally. You don't need to write this down. And this becomes 3 over 12 plus 10 over 12, which gives you 13 over 12. Now the same concept applies to algebra. Let's say we are trying to add 1 over 4x to 5 over 6x squared. We need to find the LCM of the denominators. Now, in order to do this, we can write them out as a product. The 4x is 4 times x, and the 6x squared is 6 times x times x. We consider the numbers first, and I'm not going to go over how we find the LCM of the 4 and the 6. I'm going to take it as given, and you know that it is 12. But as far as the variables are concerned, the same process applies. There is an x here and an x here. So we take one of them, and what remains is also taken. So the LCM is 12x squared. Now we go through the same process. By what should I multiply the 1 over 4x to get the 12x squared? 3x over 3x. 3x over 3x equals 1, so this changes nothing as far as the value of this fraction is concerned. It only changes the way it looks. And by what should I multiply the 6x squared to get 12x squared? It's 2 over 2. So you have 3x plus 10 divided by 12x squared. And that's the value of your fraction. In this case, there were common factors between the two denominators, so we had to find the LCM. Sometimes there aren't any common factors. Let's look at the numerical example. For example, 1/3 plus 2 over 5. There are no common factors between the 3 and the 5. In this case, we simply multiply the 3 by the 5. The common denominator is 15. And you ask yourself, by what should I multiply the 1 over 3 to become something over 15? It's obvious that it's by 5 over 5. You might ask yourself the question in a different way. 15 divided by 3 is 5, times 1 is your 5. 15 divided by 5 is 3, times 2 is 6. And this gives you 11 over 15. Now the same thing applies to algebra. If you have two fractions whose denominators have no common factors, for example, 2 over x plus 1 minus 5 over 3x minus 1. Obviously, x plus 1 and 3x minus 1 cannot be factorized, and obviously there are no other common factors between the two denominators. So the common denominator is simply the product of the two denominators. And if you want to do it the long way around, effectively what you are doing is multiplying this by 3x minus 1 times 3x minus 1, and here you're multiplying by x plus 1 over x plus 1. But if you want to write it out quickly, the common denominator is x plus 1 times 3x minus 1. This divided by that, x plus 1 cancels out, you're left with 3x minus 1, so 2 times 3x minus 1 minus the common denominator divided by that leaves you with x plus 1, so minus 5 times x plus 1. And obviously this needs simplification, collecting like terms. This is 6x minus 5x, so you're left with x minus 2 minus 5 is minus 7 divided by x plus 1 times 3x minus 1. Please remember, keep the denominator factorized. You do not need to expand it out, because this way is easier for processing later. Whether you want to multiply it, it's easier for cancelling it out, or if you want to add it to something else, you will need to see the factors between the two denominators. Another example. Consider 2 divided by x minus 1 plus x over x squared minus 1. Now obviously this denominator cannot be factorized, but this denominator can. So what's the LCM? We have to consider the LCM. So the first expression is simply x minus 1, whereas the second denominator, when factorized, gives me x minus 1 times x plus 1. Those two are common between the two denominators, so the LCM will contain one of them, and everything else that's left is taken into the common denominator. Therefore, the common denominator is basically x minus 1 times x plus 1, which is this denominator. So, this equals, again, we keep the new denominator in factorized form, divide the new denominator by this one, you're left with x plus 1, so 2 times x plus 1, plus this divided by the x squared plus minus 1 is 1, so you're left with an x here. And this gives you 3x plus 2 divided by x minus 1 times x plus 1. This is the process and this is the concept. However, sometimes you may end up with more complicated expressions whose lowest common multiple you need to find out. For example, what if you want to find the common denominator between x squared minus 4, or I mean the lowest common multiple of x squared minus 4 and let's say x squared plus 5x plus 6. The process is exactly the same. You factorize this and it's x plus 2 times x minus 2, and you factorize this and it's x plus 2 times x plus 3. Therefore, the LCM is equal to, those two are common, so you take one of them and all that's left is also taken into the LCM. So if those two are denominators of two fractions, the common denominator of the sum would be this expression that will be a cubic if factorized. That's why it's much better to keep things in factorized form. And let's apply what we have learned about factorization of the difference of two cubes. Let's say your first expression is x squared minus 9, and your second expression is x cubed minus 27, and you want to find the LCM for those two expressions. This is the difference of two squares, x minus 3 times x plus 3, and this is the difference of two cubes. So you take the cube root of the first, same sign, cube root of the second, times this term squared, change the sign, the two terms multiplied by each other without the negative, plus this squared. You check, you will find that the x minus 3 is common between the two expressions. It's a common factor. So the LCM will be x minus 3 times x plus 3 times this quadratic expression that cannot be factorized. So the principles are very similar to what we did with numbers, but you need to apply your skills in factorization.